going to share with you a step-by-step solution to West African Senior School Certificate Examination Physics Practical Alternative B Question 2. You have been provided with a drawing board, drawing sheets, rectangular prism, optical pins, thumb pins, and other necessary apparatus. You will need a protractor, a ruler, and a pencil for this experiment. So, with the aid of the thumb pins, we fix the drawing sheet on the drawing board. Then we trace the outline ABCD of the rectangular prism on the drawing sheet. Then we remove the prism and draw a normal N1. For the normal, let's put a point on the outline AB. That is the point of incidence. And the normal is always 90 degrees to the outline. So we put the protractor on the sheet such that this line falls on the glass outline and the point here falls on the point of incidence, and then we measure 90 degrees. And then we draw a straight line passing through these 2 points. That's the normal, which is 90 degrees to the outline AB. We name here O and here E. We are going to draw the incident ray, which is 25 degrees with the normal. So with our protractor, we make sure this line falls on the normal and the point here falls on the point of incidence. And we measure 25 degrees from here. This is 10, 20, 25 degrees. We put a point there. And draw a straight line from that point to the point of incidence. This is G, and we draw the arrow. The angle of incidence is 25 degrees. So we indicate it on the drawing sheet. Now we are going to place two pins P1 and P2 on the incident ray and replace the glass prism on its outline. Make sure the points are at least about 5 centimeters apart as a precaution. We replace the glass prism on its outline. And we are going to view the pins from DC and place two other pins P3 and P4 such that P1, P2, P3 and P4 appear to be in a straight line. Normally you close one eye and move your head until the two pins are in a straight line. Now the two pins are in a straight line, so we put another pin in their path. That is pin 3. And we fix another pin at about 5 centimeters apart in the same straight line. As viewed from the glass. So the four pins are in a straight line. So we are going to remove the prism and the pins as well. This is P1.1 and then point 2. And this is point 3 and point 4. So we join these 2 points to meet the glass outline at F. And then we draw another normal N2 at this point F. So we measure 90 degrees at F. And draw a straight line at F, which is 90 degrees to the outline. and name it N2. Then we join O to F, that is the refracted ray. Then we name here R, that is the angle of refraction. This line is labeled L. That's the length of the line joining O to F is L, so we draw it. And the line from the point E to F is named M. And we are going to measure the values of R, L, and M. So we make sure this line falls on the normal and the point here falls on the point of incidence, and we measure from 0, we have 10, and this is 15, and I think we have 16, 17 degrees. So we indicate it on the drawing sheet that R is 17 degrees. And with the ruler, we measure the length L, which is the distance between O and F. And from E to F, we have 2.1 centimeters, which is M. So we have our angle of incidence I, which is 25 degrees, angle of refraction R, 17 degrees, and L is 7 centimeters, M is 2.1 centimeters. So we evaluate sine I. So sine 25 degrees will give us 0.42, and we evaluate sine R, which is sine 17, which is 0.29, and here K is the addition of sine I and sine R. So we add 0.42 to 0.27, which is 0.71, and we evaluate T, which is M divided by L. So our M is 2.1, we divide by 7, and we have 0.30. We want to keep all these values in 2 decimal places. So it's 0.3, but we write 0.30. And we are going to repeat the procedure for an angle of incidence of 35 degrees 45, 55 degrees, 65 degrees, and measure and record the values R, L, and M in each case, and evaluate sine I, sine R, K, and T. So with another drawing sheet, we repeat the same process but with an angle of incidence of 35 degrees, and then measure R, measure L, measure M, evaluate sine I, evaluate sine R, evaluate sine I plus sine R, which is K, and evaluate T, which is M over L. And we repeat the same procedure on another drawing sheet using an angle of 45 degrees. That's the angle of incidence. We repeat the same thing for an angle of 55. We repeat the same thing for an angle of 65 degrees and fill the table. We are going to plot a graph with K on the vertical axis and T on the horizontal axis. So we need the values of K. K has no unit because sine I has no unit and sine R has no unit. So when we add the two, no unit for them. T has no unit because M is in centimeters, L is also in centimeters. So when we divide, they cancel out. The units cancel out. So for the plotted values, we need the values of K. The values are all decimals, and it will be very difficult to plot decimals on a graph accurately. So we convert them to standard form. We move this point twice to the right. So we have 71 times 10 exponent negative 2. That's standard form. And we move this point to twice to the right. So we have 94. When we move this point 1, 2, and we have 118. The next one is 136. The next one is 151, all times 10 exponent negative 2. For the values of T, we move this point twice, 1, 2, and we have 30 times 10 exponent negative 2. The next value will be 37. The next one, 47. The next one, 54. The next one, 60. All times 10 exponent negative 2. So the values are now in standard form and they can be easily plotted on the graph. So we draw the vertical and horizontal axis. We are going to plot K on the vertical axis and T on the horizontal axis. So we choose a scale for the values. Looking at the values, a scale of 2 centimeters to 20 times 10 exponent negative 2 on the K axis will be okay. So we start from 0 here, 20, 40, 60, 80, 100, and so on. For the T axis, we choose a scale of 2 centimeters to 10 times 10 exponent negative 2. So from 0, we move to 10, 20, 30, 40, and so on. For the first value, we have 71 on the k-axis and 30 on the t-axis. For the k-axis, one full box is 20. When we divide by 10, one small box will be 2. On the t-axis, one full box is 10. When we divide it by 10, one small box on the t-axis will be 1. So this should guide us to plot the values. One small box on the vertical axis is 2, and one small box on the horizontal axis is 1. So for 71, between 60 and 80, we have 70 at the middle, and 71 will move to the next box, between the next box. And for the t, we have 30, so we'll put the point here. For the next point, we have 94 and 37. This is 30, we count 7 boxes. And for 94, between 80 and 100, we have 90. And for 4, we move 2 boxes. So we put the point here. So the next one, we have 47 and 118. So this is 40. We count 7 boxes. And for 118, this is 100. And 118 will be somewhere around this point. Thus, we count 9 boxes, since each box is 2. The next one, 54. This is 50. We count 4 more boxes for 54. And for 136, this is 130. And we move 3 more boxes for 6. So we have the point around this place. And the next one is 60. This is 60 on the t-axis. 151 on the k-axis. This is 150. That's the middle of 140 and 160. So for 151, we'll move into the next box for the 1. And we draw the line of best fit, passing through as many points as possible. We are going to determine the slope S of the graph. So for the slope, we draw a horizontal and a vertical line like this. We name here A, here B, and then C. The slope is given by change in BC over change in AB. So for change in BC, we have 150 minus 90. Remember, times 10 exponent negative 2. And for change in AB, we have 60 minus, this falls on, I think, 36. Remember, times 10 exponent negative 2. So times 10 exponent negative 2 will cancel out. And 150 minus 90 is 60. And 60 minus 36 is 24. So we divide 60 by 24 and we have 2.5 as our slope. Now we are going to evaluate eta is equal to the slope minus 1. The slope is 2.5, so we are going to subtract 1 from the slope, and we have 1.5. The answer should be approximately equal to the refractive index of the rectangular glass prism used for the experiment.